To reach global net zero targets, we have to rapidly overhaul our energy-wasting buildings. This process, known as a building energy efficiency retrofitting project, is currently happening at a scale the world has never seen before. But there's a bottleneck. Most building owners see these retrofits as an unpredictable financial risk, making them hesitant to invest in green upgrades. When an audit begins, engineers typically start with the most basic data available, monthly utility bills. They feed these monthly totals into physics-based simulation software to guess exactly where that energy is being consumed inside the building. But these simulations are built on assumptions. They assume ideal equipment performance and perfect human schedules, often missing the real-world failures happening inside a functioning building. Relying on these simulations is like performing surgery while blindfolded. It leads to inaccurate cost estimates and ineffective upgrades that do more to drain bank accounts than save carbon. To see the impact of this guesswork, we can look at a study of 2 all-electric office buildings in Milan, Italy. Based on standard simulations, the building was prescribed a $1.38 million hardware overhaul, including entire chiller replacements and new window shading. For the owners, the math didn't work. The simulation projected a payback period over 15 years. Instead of following the simulation blindly, the team installed an energy monitoring system to see what was actually happening. They placed 52 separate meters throughout the facility to track individual energy loads every 15 minutes. Within the first few months, the real-time data proved that the $1 million simulation was wrong. The monitoring data immediately contradicted the model's findings regarding the main cooling units. While the software demanded replacing both chillers, the sensors showed that only one was underperforming. This scatter plot shows energy consumption relative to external temperatures. There is a clear 30% efficiency gap between chiller 1 and chiller 2, meaning only the least efficient unit actually required replacement. The audit then turned to the chiller pumps. The simulation guessed these were operating as expected. The reality was that the pumps were running 11 hours a day, year-round, for no reason at all. They were using 4 times more energy than the model predicted. Finally, the team looked at the air handling units, which control the building's ventilation. The logs showed these units were blasting conditioned air throughout the facility on weekends, even when the offices were entirely empty. The true drivers of the energy bill weren't just old machines. They were scheduling errors and human mistakes that a physics simulation could never detect. Armed with exact data, the team implemented zero-cost measures. They simply fixed software schedules and adjusted temperature set points. These data-driven fixes eliminated the need for most of the expensive physical construction the simulation had demanded. The financial result was a massive shift in the project's ROI. The required investment plummeted from $1.38 million down to just $226,000. But here's the most interesting part. Despite spending 80% less money, the total energy and emission savings actually increased by 53%. The diagnostic tool itself, the energy monitoring system, paid for itself in just 2 years. Before spending millions to reach net zero, we have to recognize that our buildings are already talking to us. We just need to start using the right tools to listen.